Good morning, student. In the previous video, you have discussed the solid state of the matter, and the solid state of the matter. In the previous lecture, is the classifications of the solid state of the matter in the two types: is the crystalline solid and amorphous solid. And this the crystalline solids of the matter. The regular repeating arrangements of the patterns of the solid is called particles is called as crystalline solid. In this crystalline solid are the classified into the four categories. There the classifications of crystalline solid is four categories like ionic solid, second is the covalent network solid, third is molecular solid, and fourth is metallic solid. And you are discussing the first the ionic solid and ionic crystal. The ionic crystals, the ions are the formed in the two types, the cations and anions, and the constituent particles are the charged ions like the cations and anions. And these cations is the positively charged species and anions is the negatively charged species. This cations is the size is the larger size and anions is the smaller size. And the examples like, for example, the NaCl crystal. NaCl are the examples for the ionic solid of the crystal. In this examples, NaCl, and next the dissociations of the NaCl molecules and to give the Na positive plus Cl negative anions. Na positive ions or Cl negative ions. This Na positive is the cations and Cl negative is the anions. This Na positive is the positively charged cations and negatively charged anions. And next, in the positive and negative, the size of atom depend on the positively charged and the negatively charged anion. And anions is the larger size and cations is the smaller size. The cations is smaller size of Na is the positive charge and anions is the negative charge. And next is the particles are held by electrostatic force of attraction. Second point we have discussed that the particles are held by the electrostatic force of attraction. In this, the ionic crystals or ionic bond, this NaCl molecule, the formation of ionic bond. Ionic bonds is the formations with the Na positive and Cl negative ions are formed, and this formation of the bond is in the ionic bond. The complete transfer of the electron from the one atom to the another atom. Na positive is for loss of one electron and to use the Na positive charge, and Cl to gain of one electron and to use the negative charge, and the formation of the bond is the ionic bond. In the NaCl molecules is the ionic solid. In the ionic solid, to formation of the ionic bond, the complete transfer of the electron from one atom to the another atom, and the formation of the bond is called as the ionic bond. The positive charge and the negative charge. The positive charge formation, the loss of one electron, and negatively charge is the gain of one electron in the Cl atom, and to use the compound is the NaCl compound in the ionic solid. And next point, this ionic solid, the hards and brittles. These ionic solids are hard and brittle, and they have the high melting points. High melting points of this ionic solid in the hard and brittles. Brittle means their breaking is simply because these ionic solids are hard and brittle, and the melting points is the very high. Strong metals and the compound is the form, and their melting points is the very high. And next point, the non-conductors of the electricity and the solid state and the melt or dissolve in the water to the good conductors of heat and electricity. First points and the 4 points, the non-conductors of electricity, non-conductors of heat electricity, then the state is the solid state. Solid state of this ionic solid and the non-conductors of electricity. Electricity cannot be passed in the solid state, but in this solid state of the ionic solid can be made or dissolved in the water are the good conductors of heat and electricity. And the electrolysis method in the chapter number fifth, electrochemistry. In this electrochemistry, the dimension or electrolysis of the NaCl saltrates, and these methods are the used for the dissolutions of the water and the dissolutions of the NaCl and the good conductors of heat and electricity. And new electricity are the passed in the melted compound or dissolved water and the good conductors of electricity, but cannot be passed the electricity in the solid state of the ionic solid. Next topic, in the types, in the classification of the crystalline solid, the next point is covalent network solid. In the covalent network solid, the covalent bond is the formation in the previous standard in the chemical bonding, and formation of the chemical bond or covalent bond. The covalent bond formation, the equal sharing pairs of the electron between the two atoms. And दो एटम है तो दोनों एटम में इक्वल शेयरिंग पेयर्स ऑफ इलेक्ट्रॉन जब होता है तो उसमें क्या होता है, आयोनिक बॉन्ड फॉर्मेशन. दोन एटम्स असतील, दोन्ही एटम मध्ये जर इक्वल शेयरिंग पेयर्स ऑफ इलेक्ट्रॉन जर असतील, फॉर एक्झाम्पल मध्ये मी जर या ठिकाणी कोव्हॅलेंट नेटवर्क सॉलिड मध्ये एक्झाम्पल जर आपण घेतले तर एक्झाम्पल मध्ये H2 मॉलिक्यूल, CH4 मॉलिक्यूल, नेक्स्ट इज द H2O मॉलिक्यूल or CO2 molecule, and this is the molecule. Next, the covalent network solid is, for example, H2 molecules. In the examples of and next is the covalent network solid. In the covalent bond formation, the equal sharing pairs of the electron between the two atoms. Equal sharing of इलेक्ट्रॉन्स, यानी इलेक्ट्रॉन जो है इक्वल शेयरिंग फॉर्म करने की वजह से जो फॉर्मेशन होता है बॉन्ड इज अ कोवेलेंट बॉन्ड. एंड द कोवेलेंट नेटवर्क सॉलिड, द एग्जांपल्स लाइक द H2 molecules. In the previous video, the H2 molecule formation is the hydrogen and hydrogen is a single bond, and this hydrogen single bond, hydrogen is the atomic number is 1, and the one of the electron present in the hydrogen atom, and another hydrogen atom one of the electron present, and the valence electronic configuration 1s1, that one electron is in the one hydrogen atom and another one electron present in the another hydrogen atom, and the equal sharing electron between the two atoms in the formation of the bond is the covalent bond. And the covalent network solid, in the covalent network solid, the constituent particles of the covalent network solids are the atoms. And in this example, H2 molecules, the two atoms is the equal sharing pairs of the electron between these two atoms and the formations of the covalent network solid. And this covalent network solid, the constituent particles of the network solid are the atoms, are two atoms. The link back, and these molecules, covalent network solids of crystals are the linked by constituent systems of the covalent bond in the three-dimensional structure. These covalent network solids are the three-dimensional structure, 3D structure, and three-dimensional structure like the examples like diamonds. Diamonds are the allotrope. In the previous video, we have discussed the isomorphism and the polymorphism, and the allotropic forms of the carbon atoms in the three allotropes. First is the diamond, second is the graphite, and third is the fluorine. And this is the various allotropic forms of the carbon atom and the three-dimensional structure in the covalent network solid. Next is these covalent network solids are the hard to the high melting and the boiling points of this covalent network solid, because this covalent network solid is the very hard. Diamond is the hardness property is the very high, and the melting point and the boiling point is up to the 3000 Kelvin temperature and the melting and boiling point. And next to the diamond, examples like the diamond quartz and the boron nitrides are the examples of the covalent network for solid. And this covalent network solid is the diamond is the hardest material, quartz is the silicon dioxide. In the previous video we have discussed in the quartz is the beta quartz, alpha quartz, and the crystallographites or the examples of the glass material. And these all the types of the glass materials are made up by the silicon dioxide. And the next is the boron nitride. In these boron nitride or the examples are the covalent network solid. Next type we are discussed in the molecular solid. In the molecular solid crystals, in the various types of the molecules like the H2 molecules, carbon dioxide molecule, CH4 molecule. But these the covalent molecular solids are discussed. In the first points is the constituent particles of the molecular solids are molecules like the examples like the Cl2 molecule. Next is the H2 molecules and CO2 molecules. And these the molecular solids are differentiate on the responsible forces, and these responsible forces means molecules are held by the various intermolecular force of attraction, because this the intermolecular force of attraction is the very strong and the formations of the solid state. In the first we have discussed in the first video in the solid state of the matter. In the solid state of the matter are for to the intermolecular force of attractions between the two atoms or various atoms and responsible for the formation of the solid state of the matter. And this is the point, second point, the molecules are held by the various intermolecular force of attraction. Intermolecular force of attractions, like the first is the weak dipole-dipole interactions. In first point is weak dipole-dipole interaction. Is the dipole-dipole interactions like the polar molecules like HCl molecules. HCl molecules is the polar molecule because these polar molecules are dissociate in the strong extent or strongly extent dissociate with the HCl molecule, because in the dissociate in the water the 100% with the dissociate in the HCl molecules. Numbers of H positive and numbers of Cl negative are formed in the dissociations of the HCl molecule. And this is the examples for the weak dipole-dipole interactions we have discussed in the previous standard, the state of matter. And next point is the intermolecular. Next is point is the very weak dispersion and London forces. Very weak dispersions and the London forces. These London forces, because the formations of non-polar molecule, London forces, these non-polar molecules are the weakly dissociate and discussed in the previous standard, the solid state of the matter. And next is the intermolecular hydrogen bonding. This intermolecular hydrogen bonding, the formations of the hydrogen bond. Hydrogen bond is responsible to the formation of the hydrogen bond. This, the intermolecular hydrogen bonding and the intramolecular hydrogen bonding, those are the difference between the intermoleculars and the intermolecular hydrogen bonding. First, the water molecule, one of the water molecules are formation to the hydrogen bonding to the another hydrogen water molecule, and these types of the bonding is the intermolecular hydrogen bonding. The examples like these H2 molecules. H2 molecules are these oxygen are the highly electronegative elements and hydrogen is the small electronegative element, and this hydrogen is bonded to the another oxygen atoms of the another molecules of the water molecules, and this hydrogen next oxygen atom and hydrogen atom. This hydrogen atom is the partially positive charge, oxygen atom is partially negative charge. Another water molecule is bonded with the another hydrogen atom, this partially positive charge. Next is the oxygen atom, and next is hydrogen atom is the partially positive charge, and this oxygen atom is the partially negative charge. And these types of the bonding is the intermolecular hydrogen bonding, and another is the intramolecular hydrogen bonding. This intramolecular hydrogen bonding, those hydrogen atoms are formations of the molecules, those itself molecules, and examples like nitrophenol or ortho-nitrophenol. This ortho-nitrophenol, this nitrogen atom and two oxygen atom. This oxygen atom is a partially negative charge. Another, this oxygen atom and hydrogen atom, and this is the oxygen atom. Formations of these bond, it is the intramolecular hydrogen bonding. And one of the atoms that form in the bond is the oxygen and hydrogen, and these types of the bonding is the intramolecular hydrogen bonding, and these types of the bonding examples like the S2 molecule or the intermolecular hydrogen bonding. And this is the molecular solid, and these molecular solid examples like the HCl molecules, Cl2 molecules, and next H2 molecules are carbon dioxide. And next we are discuss are the molecular solid are these weak intermolecular force of attraction, or the example the force of molecular attraction is the very weak, and these are the low melting point. अभी melting point जो है किसमें molecular solid में low melting point किसकी वजह से, because इसमें इंटरमोलिकुलर हाइड्रोजन बॉन्डिंग फॉर्म करने की वजह से सॉलिड मॉलिक्यूल जो है मोलिकुलर सॉलिड में क्या होता है, वीक मेल्टिंग पॉइंट. एंड नेक्स्ट लास्ट पॉइंट में हम डिस्कस करेंगे कि पुअर कंडक्टर्स ऑफ हीट एंड इलेक्ट्रिसिटी एंड गुड कंडक्टर्स ऑफ इंसुलेटर. पुअर कंडक्टर्स ऑफ हीट एंड इलेक्ट्रिसिटी इन द मोलिकुलर टाइप्स ऑफ द solid or crystal, because is the solids conductor electricity, bad conductors of electricity, but these are the good conductor, good insulator. And next last type is the metallic solid, and these metallic solid are the formations of the metallic bond, formation of metallic bond, and to give the metallic crystals are the constituent particles. Constituent particles are the metallic solid, and the metallic solid are the good conductors of heat and electricity. And the examples like the sodium, potassium, lithium, calcium, next copper, iron, cobalt. These are the examples of the metallic solid of examples of the metallic solid. And this is the good conductors of heat and electricity. The constituent particles are the mobile charge. Mobile particles. These mobile particles are constituent C electron, and these C electrons are delocalized, and the formations of the metallic solid of the crystal. And the metallic solid are the examples of the sodium, potassium, copper, and these are the four types of the crystalline solid. With crystalline solid, first the crystalline solid is the regular repeating arrangements of the pattern, and these patterns in the next four types of the crystalline solid is the ionic solid, second is the covalent natural solid, and next molecular solid and metallic solid. And we are discussed in the next video is the types of crystal, and the types of crystal in the next video. Thanks.